Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering module number 4 and lecture number 42. Mainly we are looking at projection of solids. For these solids, mainly we have two classification. One is polyhedra, other one is solids of revolution. In polyhedra, we have different varieties like tetrahedron, cubes and octahedron. So, if we are looking at this object tetrahedron, we have 4 equilateral triangular faces. So, this is the first face, second one and third and fourth faces. So, in that way we have this tetrahedron 4 faces. Similarly, if it is a cube or hexahedron, we have these 6 faces. Cube by definition equal size faces. Similarly, the other ones. In octahedron, we have 8 equilateral triangular faces. So, equilateral triangle every time we have to construct, assemble it in such a way that it makes a closed object. Such kind of thing what we call as this octahedron. Based on how many sides we have different numbers. And in today's class, we will see if such kind of objects are oriented in 3-dimensional space, how to draw those pictures based on how much inclination angle they make it with the horizontal plane, vertical plane, whether apex is on horizontal planes or vertical planes and so on, whether it is inclined. Similarly, we have dodecahedrons, isosahedrons and different kind of objects. These are come under category of polyhedra. Similarly, there is another set called solids of revolution. So, you pick a curve, rotate that curve around an axis, then we will get these 3-dimensional objects. Let us look at that. For example, a line, another line and another line. If we join that, whatever the plane we get, that plane if we are revolving around this axis, then we will end up with a cone, a 3-dimensional solids of revolution we will have it. So, this revolving object is about this axis. If it is just a line, for example, only a line, if we revolve around this axis, we get a peripheral surface of a cone. For example, here this is the line which is at a distance r1 and r2. If this line we revolve it, it makes a peripheral surface in that way, which is what we call conical frustum. If it is a plane, this entire plane revolves around this axis, then we will get a conical frustum of solid object, that means material will be filled inside also. Similarly, a line revolves around this axis, gives us cylindrical surface, a plane, rectangular plane revolving around that axis gives us a cylinder. Similarly, if we have curves, for example, this curve. It can be semicircle, it can be slightly elongated semicircle also. If we revolve it, ellipsoidal kind of objects we will get, and usually we call these are spheroids. From spherical geometry we construct them. And oblate, you will have pushed in this direction, elongates in that direction, we call oblate spheroids, and if it is extended in that direction, pushed in this direction, we call that as polar spheroids. And any part of the curve plane, if we revolve it, we will get different kind of objects. And in our projection of solids, we will learn about mainly the cones, frustums, cylinders, how they really look like on different planes. Similarly, there are different kind of objects which are called prisms. A polyhedra formed by two equal parallel regular polygons, end faces connected by side faces, which are either rectangles or parallelograms, such kind of objects what we call as prisms. Here let us look at this. This is a square or rectangle, another rectangle on the back side and another rectangle on the bottom side. So, the complete volume filled by such kind of object what we call triangular prism. To get square prisms, we have to connect these rectangles in such a way that from this view it makes square. Similarly, if we are picking rectangles, connect them across this pentagon, we get pentagonal prism. So, the material has to be filled inside that, then only we will call it as solid. Similarly, these rectangles connected in hexagonal framework and maybe in octagonal. If it is circle, we get cylinders. After prisms, there is another object what we call pyramids. A pyramid is a polyhedra formed by plane surface as its base and a number of triangles as its side faces. All these should meet at a point called vertex or apex. For example, let us take triangular pyramid. We have these triangles. All these are meeting at one point. This one is apex or vertex. Similarly, let us pick square pyramid. We have triangular faces. All are again meeting at that point, and the base is a fixed object. Here in this case, it is a square. So, it is called square pyramid. Similarly, rectangular pyramid having base, pentagonal pyramid having a base of pentagon, and hexagonal and octagonal pyramids also. If we have a pyramid, take a slice, this is the pyramid, it might be right angular kind of thing, vertically making 90 degrees, or perhaps a slightly slanted one. If we are taking a slice at this level, passing a plane, taking a slice of that, it makes a frustum. So, the leftover part what we call frustum, and the top apex part has to be removed. Similarly, if we have a cone, it can be right circular cone or perhaps it might be having a slant edge. If we are making a slice at this level, remove this apex portion, this entire part, the leftover part what we call frustum of a cone. So, truncated pyramids have such kind of shape where the top portion is removed. Any lines which are not visible and maybe perhaps at the back side, we usually show it by dashed lines. When we are looking from this view, the back side line we can't really see, because it is a solid object, it is not directly a transparent kind of object. So, in that case we will show it by dashed lines. So, when we are drawing these solids, there are few tips which we have to follow, especially when drawing the orthographic views of an object. It will be required to show some of the hidden details as invisible. That gives us a feeling that it is not 2-dimensional object, it is a 3-dimensional object, and these are shown on the orthographic views by dashed lines. For example, if we have a square, just to indicate that back side we have this surface, we show it by dashed line. For example, we are looking from this direction, not in that direction, then this cone this cube really looks like this one. If we are looking from this view, this line will be visible, perhaps it might be coming that, this line naturally comes there, and this line perhaps going at back side. This is the way we represent that when we are showing these orthographic views, projections. For example, let us consider a frustum. That means some part we have removed it. Frustum by definition it might be having a cone or pyramid kind of shape or perhaps pentagonal thing, and one part we have removed, and the part what we have removed is apex side of that part. That means in this case the size of this pentagon is way smaller than the size of this pentagon. That means these lines go intersect far away and make something like apex, and that part we have removed it, and the leftover part is this, and that frustum what we are trying to look at. So, when we are looking at that, naturally in any engineering drawing we have to represent by that letters. Our standard convention is these 3-dimensional kind of objects we show it by capital letters and projections by small letters. So, let us call part A, B, C, D, E. Through these edges these lines are passing. Similarly, the bottom ones let us call A1, B1, C1, D1 and E1. It is a complete solid object and this line is at back side of that. That is the reason we show it by dashed lines, which are usually not visible, whereas these lines are in front of us. So, these lines are always be visible. And second thing, edges are always be visible. If you are picking any object, back side we might not be in a position to sense it, but front side the edges are always be visible. That is also one of the reason we show it by dark continuous lines, whatever not visible by dashed lines. Let us carefully look at these ABCD terms step by step. ABCD is the highest points what we can see, and these are visible. So, we show it by continuous lines is top view. Now, let us look at edges. The edges are A, B, B, C, C, D, we will write it. That is the reason we are showing these lowercase letters, and especially these supposed to be full lines in the top view. For example, we are looking from this direction. This might be the front view, top view. When we are looking top view, this one, this is the horizontal plane and this is the vertical plane, x coordinate, y coordinates visible. So, perhaps our pentagon looks in that way. Now, this one because we are looking from top and it is a solid object, it is not straightforwardly transparent thing. So, we can't really sense this A1, B1, C1, D1, E1 in the top view, but this area smaller than this area, let us call area naught and area 1, area naught is greater than area 1. In that case, what we will see is somewhere here is a frustum. If we want to really represent this area 1 completely in the picture, then these things really comes in the inside of that object. So, in the top view, this bottom one is invisible and these A, B, B, C, C, D, E, A are full lines in top view. So, if we are representing A, B, C, D, E are visible, whereas these A1, B1, C1, D1, E1 these are invisible. So, A1, B1, C1, D1 and E1, this is the way we should write it. Similarly, any line connecting a visible point and an invisible point is a dash invisible line. For example, this is a frustum of a cone. So, for example, this point A connects to this A1, is we do not really see this line when we are looking from top view. What we will see is the top pentagon, bottom one is anyway invisible, and the line, because we are looking from top view, this line goes inside of that. So, it is beyond our visibility. When we are representing this A1 to A1 whatever connection, that is always be invisible. Point A is visible, A1 is invisible point. Unless these are outlines, we show them by dash lines. Any outlines or the edge kind of things, we have to show it by continuous lines. Let us take the top view. So, top view we are looking at from that direction. So, xy plane, horizontal plane, like what we have guessed, ED, AE, AB, BC, CD are visible. This is always be visible. Inside one not visible, not visible lines. Similarly, when we are looking A to A1, there is a line, this one. So, let us use some other color. This line is not visible when we are looking from top view, and that is this line. Similarly, let us connect C point to C1 point, this one is also invisible. So, C to C1 invisible. Similarly, D to D1. So, D to D1. That way we join these lines. Let us look at front view. So, when we are looking front view, these points mapped all the way to that one. Similarly, this point all the way mapped to this C1. Similarly, each and every point mapped there, A point, E point, D to D, C to C, B to B points. This is the way we connect these maps. Once done, from the front view, we will be in a position to see the slant edge. So, that slant edge is this one. Because we are looking from front view, we do not know this E1. I do not know in the sense these are not visible lines. So, connect E1 to E prime by dashed lines. Similarly, point D to D1 also invisible from this front view. So, join them by dashed lines. Now, B to B1 always be visible in the front view. So, we join that by a continuous line. What about side view? So, we have to look from that side. When we are looking from that side, this one always be visible. This line also will be visible. Possibly this line also visible in that side view. So, let us look at that. So, this A1 we can clearly see that visible. This B1 will also be visible when we are looking from side view. Similarly, E to E1. E to E1. Because it is a pentagon, naturally asymmetry is there in terms of this line. So, this AE line might be elongated one and this AB line might be shortened, because we are looking from left side view what we have on the profile plane. Now, let us ask a question. If a cylinder or cone is placed on horizontal plane, how it looks like? What are the projections for that solid? So, let us consider this cylinder. It is a solid object. Axis is that. Now, this cylinder is placed on horizontal plane. So, again construct our 3D picture. This is the vertical plane, this is the horizontal plane, and what we have is cylinder resting on horizontal plane. That means, this might be the cylinder goes in that way, because some part is invisible when we are keeping. So, this part dash 1. So, we want to look at from this view. If you are seeing, these points will be mapped all the way there. So, what we will see is such kind of rectangle, and this one mapped to a circle, and when we are rotating it, this is the place where we get this circle. So, same thing what we can observe it on this projection plane. For cylinder, the edges, because it is having many edges on that side, whatever the atmos which is at a given radius, that edge we will be in a position to see that. And base, this base is resting on horizontal plane. So, that is the reason it is on xy axis. Second thing, whenever we are drawing these cylinder symmetric kind of objects, we always show by axis dash dot lines. Similarly, for circle dash dot lines we will show it. Now, if a cone is resting on horizontal plane, how it looks like? Same way, this is the horizontal plane what we are intended for, and this is the vertical plane. So, project that, and this edge map happens, that one also happens. So, what we will see is a triangle there, which is this. When we are projecting on the horizontal plane, we see a circle and rotate that onto this horizontal plane, then we will see it as a circle, and that is the one what we are seeing. Let us look at this example. If a prism is placed on horizontal plane, however, at different directions. So, this prism is always be placed on horizontal plane, but one of these edges making different inclination angles. If so, how it looks like? For example, one of the edge on the base, because this is the one which is placed on this vertical plane, horizontal plane. So, this is the horizontal plane what we have, this is the vertical plane, horizontal plane, and that is the vertical plane. When we are projecting that, we will have such kind of arrangement. The first one what we are trying to look at is, in case one of these edges are rotated in such a way that that will be parallel to our horizontal plane. So, this one. Anyway, projection on the horizontal plane, if we are looking, the top view always be a triangle, and when we are projecting onto that vertical plane, because one of the face we will be in a position to see that, and that is this rectangle. The edge we always be seeing, so that will be this one, because this edge whatever the line passes through that, that we will see it as a line there. Let us rotate this rectangular face not parallel to vertical plane, but it makes an inclination angle. For example, this one, slightly rotate it in this way, then remaining edges also rotates. Now, when we are looking this entire one, this edge we will see. Similarly, this one maps, we will see that edge. This entire thing will be projected, so we will have these lines. And the axis we usually show by dash dot lines. Here axis we are not showing, because one of the face is parallel, this edge and this x axis coincides, that is the reason we are showing by a continuous line. Whereas in this case, edge, this one maps, but axis still there which is invisible. So, we are showing just by axising a dashed line. Slightly rotate these objects further, this AC have slight rotation, so that this point comes this direction, this point comes in that direction, this one goes there. If we are rotating this entire prism on horizontal plane, we will see it like a triangle. When we are projecting that, this point always be the edge. So, we will have that line. This one coincides. So, when we are looking from this direction, this entire face we will be in a position to see, and that edge we will see. This one also it gives us an edge. So, this face shrunk to this small kind of rectangle, and the axis maps by this dash dot line. Now, if we further rotate this object AC in such a way that here we have this one at the back side and this one front side for the front view. Now, flip this direction, so that this edge goes at back and this one comes front. So, this is the configuration what we will have. That means, this line is not visible, whatever the vertical line passing through that. So, A point, B points maps to this A1 prime, B1 prime, and we will see that line, and again top face we will see that, but this line we can't really see. So, we show it by dashed line. This is the way we project these solids. In the next class, we will look at more examples on this projection of solids. Thank you very much.